Alrighty, so for our video spectra problem, first we have to start out with the formula, and I got the wrong formula. There was a mistake in it, as Professor Anton gave me the correction. Thank you. So the correct formula is C11H12O3. And so the first thing that we want to do is find the IHD to see how many degrees of unsaturation that we have. And so this is the formula: 2 carbon plus 2 plus nitrogen minus the hydrogens minus the halogens divided by 2. And so as you can see, we do that correctly, and we end up with 6 degrees of unsaturation. And the important thing to note is that if the IHD is greater than 4, it strongly indicates that we have an aromatic ring. So let's look at the IR spectra, and we can see that around 1600 wavelength, we have a little peak here, and this correlates to the carbon-carbon double bond. And then come back down a little bit, we can see that around 1700 peaks we have another peak, which is very powerful, and this indicates the CO double bond. And then as we take a look a little further, right underneath the 3000 mark, we have some peaks here, and this indicates sp3 carbon hydrogen bonds. And to the left, a little bit greater than 3000, we have a level peaks, and this indicates the sp2 carbon hydrogen bond. So from this piece and this piece, we can safely assume that we have an aromatic ring. So now let's look at the hydrogen spectra. And starting off with this one right here, we can see that we have a singlet with 6 hydrogens integrated, and that heavily indicates that there is a methyl group. And this methyl group, there's probably 2 of them, so we have to keep in mind maybe symmetry. And then on top of that, because it's closer to 3, we can indicate that it's probably next to the oxygens in this formula. And so now if we look down here, if we look at these two right here, and we look at the numbers corresponding to them, they're 1 hydrogen, they're a doublet, and they also have the same coupling frequency right here. And so this heavily indicates, because it's around 6.4 to 7, this indicates kind of we have a double bond here. And so because of that coupling of each other, we're kind of going to indicate that we have a double bond that's going to be in a trans configuration. And so that's important to know. And then over here also, these 2 peaks indicate to the aromatic ring that I was talking about, because they fit in the range 7.58, 7.16. The important part here is that each of them have 2 hydrogens, and that indicates that we have a para-substituted aromatic ring, because we'll have hydrogen group here and hydrogen group here. Alrighty. And then now just kind of taking that and looking a little bit further, the carbon spectra. So the carbon spectra, we can see, because we have 2 around 50, and the 50 range, as you can see right here, is kind of the single bonds here. We don't have any nitrogen in the formula, and because it's closer to 50, this indicates the CO bonds. And then as we go back over here, we can see this corresponds to the para-substituted aromatic ring. And then right here it indicates the double bond, the CC double bond. This range, kind of 100 to 150, is the sp2 sp2 hybridized carbons. And then over here, if we look at kind of here, from 150 to 220, this is kind of where we have our carbonyl groups. And we look further into this region, you can see that closer to 150, we have the amides and the ester. And if you look here, this is a lot closer to 150, but we have no nitrogens in the formula, so we can safely assume that we have an ester. And so now taking all of these parts, kind of laid them out over here, we know we have an ester, we have a para-substituted aromatic ring, we have a double carbon-carbon double bond that is trans configuration, and we know we have a couple methyl groups, and we have some CO bonds. And so putting all that together, we come up with this structure. As you can see, we have the methyl groups on the ends, we have our ester right here, we have our trans configurated double alkene, carbon-carbon double bonds, and then we have our CO bonds that are connected to the oxygen, and then right here we have our aromatic ring that is para-substituted. So we have the hydrogen groups here, and that matches up to the formula of C11H12O3. Thank you.